Going to be the last video for 4.5, so let me get started. So they're telling us to design a 1 liter can shape wait to design a 1 liter can shaped like a right circular cylinder. What dimensions will use the least materials? So I'm asked for my least material, so I'm going to be using my absolute minimum. Okay, now what are they really asking us here? We're asked to create a can. So we're not finding the area, we're finding something called the surface area. So here I am finding the surface area. Now, the surface area of a cylinder, you don't need to know how we got it, but the doctor explained it, but يعني just the formula straight up. It is 2 pi rh plus 2 pi r squared. This is going to be my surface area. Now, one issue I have here is that I have more than one variable. I have h and I have r squared. Now, how am I going to get h in terms of r squared? I'm going to look at my given here. I'm given 1 liter. Now, whenever we solve, we never use liters. We always use centimeter cubed. And 1 liter is always equals to 1000 centimeter cubed. And this is, like we know, this is volume, right? So this is a volume. So I'm going to use the volume, which is pi r squared h of a cylinder. So memorize this one whenever I need to substitute this. And my volume is, like we said here, 1000 is equals to pi r squared h. I'm going to divide by pi r squared so I can get h alone, so I know what h is equal to. So I found my h to be 1000 over pi r squared. Now I found my h. I'm going to substitute it into my surface area, so I can have my final surface area, which is going to be 2 pi r into 1000 over pi r squared plus 2 pi r squared. Now let me erase this and write it down neatly. Now I'm only looking for the dimensions, so I don't need to really find the surface area. So now what do I need to do? I need to fix my equation here. Now how am I going to fix it? I am going to, okay, let's see here. I have this 2 pi r and I have pi r squared. I'm going to cancel a pi r from here with the pi r squared. What am I going to end up with? The surface area as 2, I'm gonna multiply this 2 by 1000, so it's gonna be 2000 divided by an r, the r here cancelled, so I have only one r left, plus 2 pi r squared. So now I fixed my equation. Now I need to find my derivative. So this is my first step. Now let me find my derivative. So I'm just gonna say a prime, because I'm not gonna write the whole thing. Now I'm going to, let me first, before I write this, let me rewrite this in an easier way. I'm gonna say my surface area is equals to 2000 r to the power of negative 1. I just took my r up, plus 2 pi r squared. Now let me solve for my area, because I cannot have r in the denominator, so I just took it up here, I fixed it. I'm going to get negative 2000 r to the power of negative 2 plus 4 pi r. So here I'm just finding the derivative. So if I need to simplify it, I'm going to say, let's put 4 pi r first, minus 2000 over r squared. This is going to be my surface area, the derivative of my surface area. Now for my third step, I need to find my critical points, like we said. How do I find my critical points? I'm going to equate this to 0. So I'm going to put 4 pi r is 4 pi r minus 2000 over r squared is equals to 0. I'm going to take the negative 2000 over r squared to the other side, so 4 pi r is equals to 2000 over r squared. Now I'm going to cross multiply. I have here over 1, so I'm going to cross multiply. I am going to end up with 4 pi r cubed. This r squared by r is r cubed is equals to 2000. Now I need to find my r. I'm going to divide by 4 pi so I can get my variable on one side alone. I'm going to end up with r cubed is equals to 2000 over 4 pi. Now don't put this on the calculator. Put it on the calculator like this. So I can find r alone. I am going to take the third root of 2000 divided by 4 pi, and once we do that I get my r to be 5.4. Now since they didn't really ask me to find any like absolute area, so I'm not gonna draw a table. Now I'm not sure if we have to draw the table in the exam, but in this question we don't need it. So I'm not really sure. Should be like, I'll just draw it anyway, just in case. So r a prime of r and a of r. We're not gonna benefit anything from this, to be honest. So let's just do it. I have from 0 to infinity, and I have my 5.4 in the middle. When I substitute a value here, so let's say I take the purple for a prime r, when I found my a prime, it was 4 pi r minus 2000 over r squared. So when I substitute any value in between 0 and 5.4, let's say I take 2, I'm going to get a negative number. And when I substitute any number in between 4.4 and infinity, I'm going to get a positive number. And then this just shows this is going to decrease, this is going to increase. I don't really have to substitute into the original equation in the second one because they did not ask me for the was in the smallest area. They asked me what dimensions, so they did not ask me for any surface area, so I don't really care about the surface area. So now I'm going to answer my question. We're gonna say the dimensions that we'll use the least material will be, then I'm going to take my radius r, which is 5.4, and then I'm going to take my height, which was, we found it to be 1000 over pi r squared, and I'm going to substitute my 5.4 into the equation, so 1000 over pi into 5.4 all squared, and I'm going to get my height to be 10.9. And also don't forget, when you're dealing with pi, switch your calculator to radians. Okay, so this is going to be my final answer when my r is equals to 5.4 and my h is equals to 10.9.